This is AWR Microwave Office tutorial series. In this video, we will learn how to set up simple inverting op-amp, both for ideal and non-ideal characteristics. And later in this video, we'll compare the simulation results for both cases. So let's get started. In the first step of this video, we are going to create the circuit schematic. To do that, we'll open AWR design environment. Now here, let's create our new schematic. Just go to project window, select circuit schematics, right click, click over new schematic button. Here we are going to name it ideal inverting amplifier. Then click over create button. Next we are going to place the components from AWR design environment library. To do that, we'll press Ctrl L on our keyboard. First we are going to place op-amp. So just search op-amp there. And we'll place it somewhere here. Let's drag this text to this position. Next we are going to place some registers. So again, go back to the library and search for registers. Next we are going to place an AC source. So we'll just search for AC voltage source. We'll place it here. And we are going to add couple of meters as well to do the measurements of input and output. And that is what we are going to do. We are going to plot for V in versus V out in time domain. So let's place V meter as well. So we'll place one here and one at the output side after making the schematic. Now after placing the required components, I'm going to create the schematic quickly. Let's change the value of these registers and the parameters of op-amps if required. So in case of op-amp, we'll just go with the default parameters. Just make this R1 to 1K. This feedback register will be 100K and the output load register will be 10K. We are going to name these meter IDs. So this will be V in and let's make it V load or V out. Once the schematic is ready, we are going to hit the zoom fit button, which is here. And in the next step, we are going to set up frequencies and other parameters before running the simulation. To do that, we'll go to project options, double click there. Let's go to frequencies tab and here all the data entries will be in kilohertz. So let's change the unit to kilohertz. In this case, the start frequency will go with 1 kilohertz and we'll go for single point. So we are going to run the analysis between V in and V out in time domain for a fixed frequency. So that's why we have hit check the single point here and click over apply. Then we'll go to global units tab, edit global units and make sure to change the frequencies to kilohertz and click over OK. After setting the project options, we are going to set up the graph and run the simulation. For setting up the graph, we have to go to again project window. Go to the graph, right click and click over new graph. Here we are going to name it V in and V out. In this case, this will be the rectangular plot and then click over create button. As you already know, we have to add some measurements on this plot. To do that, we have to right click, go to add new measurements button. Here we have to select the non-linear voltage, which will be here. And measurement will be voltage in time domain. So we have to select V time. Here we go. Make sure the data source name should be the same as your schematic name. In our case, we have this only option since we have no other schematic there. Now measurement component. So first we will select the meter we have connected at the input. So let's select that and click over OK button and then click over add. Then we are going to add another measurement. But this time we will select the output meter. Again, click over add and close it. So we have added two measurements here. One is for input, one is for output. And here you can see it's in time domain. And at last, we have to just run the simulation. To do that, we'll just click over this analyze button. And here we go. We have the input versus output. So as of now, the input voltage is too low. That's why we can't able to see the swing exactly. So we have to just make this plot to 3-axis plot. So here we have the voltage range from -100 to 100. So we are just going to shift this to other side of the plot, and here we'll have for the input. So we can basically see and compare what is the exact voltage in terms of its value. All right. Now to do that, we have to just right click over graph, go to options, then we have to select the measurements tab. For V in, we have to select the left one, and for VL or V output, we have to select the right, click over apply and OK. All right. So here you can see, let's shift it somewhere here. Okay. So here you can see on this side, you can just follow my cursor. We have the input voltage, and on this side, we have the output voltage, and input waveform is denoted with blue color and output waveform is denoted with pink color. So we can clearly see the amplification by adding markers. So we'll just right click, go to add marker, and we are going to put it at the max of input, all right, which is around 1 volt, and we'll add another marker which we'll place at the output side, which is around 100 volt. And if we'll simply apply this 20 log V2 by V1, we'll get the gain of 40 dB. All right. So this is the simulation results of an ideal inverting op-amp. Now what will happen if we'll implement the P-Spice model provided by the manufacturers on the op-amp and do the same analysis. So in the next step, we are going to run the same sort of simulation, but for non-ideal inverting amplifiers. Now to do that, we'll again go back to our circuit schematic, and I'm going to create a duplicate of that. So the goal is to remove this ideal amplifier, and we are going to replace it with sub-circuit block and assign the P-Spice model provided by manufacturer. Rest of the schematic will be pretty much same. So let's do that quickly. So I'm just going to duplicate it first. Let's rename it non-ideal op-amp. All right, let's go there, and I'm just going to close other stuff. I'm going to delete it. Let's delete these grounds as well. We'll place those later. Now before adding the sub-circuit block, if you remember from previous tutorials, we have to import the P-Spice into the netlist. To do that, we'll just select the netlist, right click, import netlist. We'll go to tutorial 11, and this is the op-amp we are going to import. Just select the lm471.lib file and click over add button. This is a P-Spice file, so let's select the P-Spice and click over OK. So this is a pretty much similar file which we have already imported in previous tutorials. So let's close this. Next we are going to add the sub-circuit block, and this is the netlist file we want in our sub-circuit, and click over OK. So now we have this 5-port sub-circuit block. Let's assign a correct symbol to that. To do that, we'll go to properties, select symbols, and we want to assign the symbol of op-amp 5. 5 means it should have 5 pins. So let's select that and click over OK. So inverting pins should be connected on this node of our input register and feedback register, and then we'll have a ground connected to non-inverting terminal. Here pin 99 is a positive supply pin, and this is the negative supply pin. So we are just going to add a DC source there. So again, go back to library by pressing Ctrl L, select DC voltage source. Okay, we'll place it somewhere here. Okay, let's make some space for that, and we'll just copy it, place it here for negative voltage. So let's make it -15 and +15 and connect these terminals to the correct voltage sources, and negative terminal will be connected to ground. Next we have to connect the output port, and the schematic is ready. Now, as we did in the previous section of this video for ideal op-amp, we have to add another plot. So let's create a new graph, or we can just copy the previous graph and update the input and outputs. So I guess that will be time saving. To do that, we have to just right click and click over duplicate. Here we go. We are going to rename it V in and V out real. Now we have to update the input and output. So let's go to the first measurement. Data source should be non-ideal and select the input meter and click over OK. Similarly, go to another measurement for VL or V out. Just double click there and we have to select the correct schematic and make sure you have to select the correct meter and click over OK. Alright, rest of the things are pretty much same. So next we'll just run the analysis. Now you can clearly see the difference between ideal and non-ideal. So here we have some distortion because of non-ideal elements of the operational amplifier. Alright, so you can simply compare the plot and see the difference in gain. So that's it for this video. We have learned how to simulate a non-ideal and ideal inverting amplifiers and how to plot for input and output voltages in time domain. Next, we are going to save this entire project. To do that, we'll go to File, click over Save Project. I'm going to save it on desktop and let's name it a non-ideal and real inverting amplifier and click over Save button. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.